Hey, this is Andrew Brown from the AWS Cloud Project Bootcamp as we continue on with our CloudFormation week. So I'm going to try to do as much as I can. If possible, I would like to try to get all of the CloudFormation code done as I was saying previously, but we'll just have to see how we do approach this. It would be nice to try to work on our diagramming as well as we do this so we can exactly see what we're doing. So what I'm going to do is open up Lucid Apps and I'm going to try to find the one we're working on there. I just want you to know that the one challenge with Lucid Apps is the fact that, well, there is a limitation of the amount of items you can make. So if you need to use Dry.io or something else because you're in the trial tier, I understand that. But that's what I want to use today. And of course, we have built this one previously, but I'm going to make a new one here. And we'll just drag this all the way to the left here. I'm just going to call this one Crutter diagram. Updated. And we'll try to provide as much detail as we can in this so that we are basically producing a physical diagram. Now, will it meet the requirements of, say, Chris Williams and Margaret? I would have to go talk to them and have a conversation. But for the time being, I'll do the best that I can. And so let's go back over to Gitpod. And so we do have the CNF directory, and we started to make a cluster. Now, this thing is not that useful for us right now. So what I'm going to do is go to CloudFormation. I'm just going to tear down what we already have. And there's a few things that I want to do. So one thing that I definitely want to do is do some networking, because we didn't really do networking that much in this course. And I kind of feel like going over the core components is very important. The reason I didn't was because I assumed that a lot of people had the networking knowledge because they had particular certifications, but not everybody has that background. So what I want to do is create a VPC using CloudFormation. And so there are a few things that we want to have. And so another thing that will be interesting is the fact that we should probably break this down into layers. And so I'm going to make a new folder here. I'm going to call it networking as our base networking layer that we plan on deploying our resources into. And so that will be there. And I'll make a new file in here, and I will just call this template.yaml. When I can just call things template.yaml, I'm going to definitely prefer doing that. And that's what I hope to do. So we have our template.yaml here. And what we're going to need is the usual AWS template format version. And then from here, we need a few resources. So what we're going to need is we're going to need a new VPC. We're going to need a VPC. We're going to need an internet gateway. We're going to need route tables. We're going to need, what else are we going to need? We are going to need VPC, internet gateway, route tables, subnets. That's kind of important. And so that seems like basically what we need. And so we need how many subnets? At least we need 3 subnets. So we'll have, subnet A, subnet A, subnet B, subnet C. And why 3 subnets? Because when you want to have availability, you want to have it across 3 AZs. So that way you'll have the best uptime. Now, where we want to launch this is going to be up to you, but we will code it so that if we want to launch this in CA Central or US East 1 or wherever, we'll have that flexibility to do so. So the first thing I need is a VPC. So I'm going to go over to AWS VPC, and I'm going to type in CFN, and that will get us the documentation that we need. So over here, it'll probably show us that we have this expanded in the area of CloudFormation templates. And the great thing about this is that if you find out where this is, I don't know why it's so hard to find today, but here, usually the things that are related are going to be side by side. So here it says specify a VPC. And if we go down below, we can see all the fields that we need. So we'll go back over here, and I'm going to type in resources. And we're going to want type. And the first type is going to be this. Now you can, if you want, you can have parentheses around here, double quotation, sorry. Or you can just not have any. I prefer to not have any. This will still get interpreted as a string, but to me it just reads nicer, so that's the way that I want to do it. We need to have a logical name for our VPC, and so I'm going to just call it Crutter VPC. Actually, we'll just say VPC here because the stack will probably be called Crutter, and so in the context of this, then the name will end up being like Crutter VPC. Right? So that's something that we just want to consider there. And I think I can name it that, and it shouldn't give me any problems. So there's the type. and we'll go down below here and we'll look at some of the properties. So the first is CIDR block. This is conditional, so you must specify a CIDR block or IPv4 IM pool ID. I don't know what this is. So the ID of IPv4 pool you want to use for allocating VPC for CIDR blocks. What is IPAM? And I honestly don't know what IPAM is. So IPAM is a feature of VPC that makes it easy for you to plan, track, and monitor IP addresses from your AWS workload. You can use IPAM automated workflows to more efficiently manage IP addresses. So IPAM is something that I don't know about. And let's go take a look at what it is, because there's always new things that AWS is introducing, and I can't keep up with it. So if I type in IPAM, would I be able to find it this way? I definitely saw it recently when I went to like the networking center, and that was something that was new for me. I had never seen it before. So I'm trying to see if I can find it here. Let's click into VPC Lattice. I'm just trying to get to anything with networking here. But I definitely know it was verified access. They're always adding stuff on me here. But there definitely is a VPC address manager. That's the thing that we're looking for. But this is in the networking center, I thought. You can use IPAM to monitor IP space across the entire AWS organization for a single account configure setting up. So IPAM makes it easier to configure. Okay, I get it, but what is it? Why? What does it do? Automate IP addresses allocation across multiple accounts. What's the pricing? Does it cost me something? There's no additional charge for creating a VPC. We know that. IPAM. You pay hourly rate of the IP addresses you manage. No way, I don't want to pay something additional, so we'll forget about that. I don't know the benefit of it right now, but that's interesting that that is an option. So by reading through these options, you really do learn exactly how these services work. And so that's why I like utilizing CloudFormation, because you have to read them all and then you know how they work. Whereas with CDK, it does a lot of that work behind you, and you might not be aware that there are certain things that must be configured. So we want to have a CIDR block for sure. So I'll go back up to our template here. We'll go properties. That's the structure. You always have a type in your logical group, and then you'll have properties. And so we want our CIDR block here. I know there's a plugin for snippets, but I'm just going to write it by hand. That's how I do it. And so we have this CIDR block here. So this is something we're going to want. So we're going to read through all the options, and then we'll circle back here. So the net mask length of the IPv4 CIDR you want to allocate to this VPC. This is for IPAM, so we'll ignore that. And then tags, we'll ignore that for now. And so, yeah, that looks pretty straightforward. It just seems like there is, well, where's all these other options? So we have enable DNS host names. Why didn't we see these? Oh, here we are, properties. I guess we must have scrolled by them. Oh, we scrolled by them. I'm sorry about that. We'll go back to the top here. So we have our CIDR block. Enable DNS host names indicates whether the instance launches a VPC gets a DNS host name. You definitely want this enabled, because then they won't have DNS host names, and you want to have that. Disabled by default for non-default VPCs for more information. So I'm pretty sure that we want to have this enabled, so we'll go here, and we'll give it a true for now. I'm going to assume that it's a Boolean, because it's probably true or false. Enable DNS support indicates whether DNS resolution is supported by the VPC. If enabled, queries to the Amazon DNS server or reserved IP will have a range of +2 to succeed. If disabled, Amazon provides a DNS service to the VPC that resolves the DNS host names. So this sounds like they're going to provide it. And so it says it's enabled by default. If disabled, Amazon provided DNS service in the VPC that resolves to your IP address is not enabled. So if it's by default, I'm going to put it in here true so that we can see that. And I'm going to be careful and just go back and read this one a little bit more. Indicates whether the instances launched in the VPC get a DNS host name. Oh yeah, we want that. So you know when you launch an EC2 instance, it'll have an IP address. It can also have a host name, like looks like a domain name. And so that's something we definitely want to be enabled. Instance tenancy, so there's default and dedicated. So this is launch into a VPC that runs on dedicated hardware by default. That's expensive. We're going to stick with the default. Again, we don't have to be explicit. Like, we don't have to specify all these things. But for our learning purposes and just to have good documentation, we'll know exactly what is set by putting these here. So I'll go back over to here, and we will just say true. And then we'll go to the next one here. And this will be instance tenancy. And so we'll go ahead and paste this in. And I'll just bump up the font as well, just so that it's a bit easier to look at. So we'll say 24. Here we go. And so hopefully that is a bit nicer on the eyes. And we will go here. And this will be set to default. Okay, we'll go back over here. So that one probably already goes to default, but we'll put that there anyway. We don't need this. We can ignore it. We don't need this either as well. And so that is all the values I think that there are for it. We can do tagging, but the thing with tagging is that you can set tags at a higher level and propagate them down. So with CloudFormation, I think we will do this at some point, but right now we'll leave the tagging alone. Not to say that we're neglecting it, but we will come back to it. Tagging is very useful and important, so it's something we definitely want to do, okay? So anyway, here we have our VPC, and so that is one component that is defined. We obviously have to keep defining more components, but to try to get into the habit of doing lots of deploys, we'll start to set that stuff up for that. So we'll go into our bin directory or CNF, and I'm going to make a new file here called, we'll rename this to networking deploy. I know this is actually for our cluster, but I'm going to modify this so that it's for a different purpose. So I'll go here and say networking. And then we will go to here. And I mean, I would rather have like a relative pathing, but we'll fix this later on. I just don't want to do that right now. I want to call this CRUDder. And we'll keep with our CNF artifacts bucket. So that's something that we definitely want to have. And we should probably document stuff as we're going along here. So I'm going to go and put this here. And then we'll just say architecture guide. So before you set up any of your, before you run any templates, be sure to create a CNF bucket that will, or a bucket, an S3 bucket, to contain all of our artifacts for CloudFormation. Okay, and so we can go here, and this would probably be AWS S3 make S3 / CFN artifacts, right? And then we would want to set that bucket name. So we'd say export CFN bucket, and then this would be whatever it is. So mine is CNF artifacts because that's what I got. And I'll just do this as well so that we have this redundantly. And so the idea is that then we can use that as our bucket that we pass in here. Okay, so I'm going to just export that, and then I'm going to do this as well. And I'm pretty sure this is the command because I've done it so many times. But you'll have to name the bucket whatever unique name that you need to have. Remember that bucket names are unique. So the provided code example you may need to adjust. Okay. But anyway, so I've set that there, and what I want to do here, whoops, I just want to make sure that's set. So let's say env grep CFN, and so the bucket name is set there. We'll go back over here, and here we can just set that there. Now I do have a really nice library that I coded. It's not that it's super complicated, but I have a library that we can use to dynamically load parameters in a TOML file. We might bring that in here, need be, but for the time being, we'll just keep it simple and just keep working through this and focus on the CloudFormation. So we have this here. It's going to the networking template YAML, and so we should now be able to run this file here. So I'm going to go ahead and execute that. So we will just go bin CFN. We have to go up a directory here. So bin CFN networking deploy. And it says property value cannot be null, resource, VPC, property CIDR block. Oh, right, we did not fill that out. And so we need a CIDR block. What's important when setting up a VPC is that we aren't conflicting with another one, because you can't have ones with the same address. I think all namespaces always start with 172.31.0.0. If you go to other ones, they're all going to be like that with size 16. The size of your VPC matters because that's going to be the amount of IP addresses you have available. There is a service called Cider, Cider XYZ, where we can kind of see the size of our cider block. So here, if we go 16, what you'll see is that we have available 65,000 IP addresses that are assignable. Now, this is not exactly true because AWS reserves a few. I think they reserve like about 5 IP addresses, so you just minus 5 to that. But my point is that this is going to limit the amount of IP addresses you have. So if you have containers, and each Fargate container has a network interface card, then they're going to have their own IP address. And so that means that in this VPC, we only have room for 65,000 containers. So you can play around with that number and figure out what you want, but 16 is what is good. Because remember, we're going to have that, and then we're going to subdivide it. So then we'll subdivide, and then we can only have so many in certain subnets. And then if you want to have high availability, you have to have redundant versions of containers, because if you have one container that fails in one AZ, then you want to forward it to another one. So it's not just a matter of you say, oh, well, I can have X amount of containers, but it's like if I have 10 services and I want to run duplicates of them, right? Then you can see how the math adds up really quickly, right? So, 100 services times 3 is now 300. And so, just that's how it works. But anyway, we'll go back over here. And so 16 is fine. And there are numbers that you can choose from that are very common. I wonder if ChatGPT would suggest some for us. But I usually go with 10.0.0.0. But we'll go and we'll ask ChatGPT, what are common... And by the way, I made banana nut ice cream using this recipe here, and it was really good. So I think that's something that I'll keep doing. But we'll go back here and say, what are common IP ranges for cider blocks when creating a new VPC in AWS? But there are reasons like why, or I would say IP, can you provide the IP address? And so here they're doing 10.0.0.0, but these used to indicate like the size of network and other things. I don't remember them. I have a networking primer somewhere in I think the SysOps associate, where I talked about these different IP addresses. But we're going to work with 10.0.0.0 because it's not in use, and so we can go ahead and use that. So I'll go back over here, and we will do 10.0.0.0/16. Now, we provided it like this because I know that's how a cider block is, but sometimes in CloudFormation, they're going to tell you what they want it to be. So here it's a string, and a cider block looks like that. So I'm pretty sure that is correct. I think the issue here was I wrote cider block, so I'm surprised it didn't give me an IP address, but we'll go back over here. And so we have this. We'll go back and hit up, and we'll attempt our deploy. And first it's zipping over to S3. It's waiting for us to create the change set. And then we'll go over to CloudFormation. And we will refresh this. And we will choose this. And we'll go over to our change sets here. And Rohini told me that we press this. That does that. That saves us a lot of trouble. And we'll execute that change set. I don't need to look inside of it. I know what it does. And so this should be pretty darn quick. And so I believe that it created it. Not yet, but we'll wait a second, okay? Great, so that is finished creating, and so we have our VPC. It's good to check out the resources to make sure they're configured the way that you want them to be, because that's how you audit them. Of course, having, if we got CFN guard working, which we will at some point, then that might be something that we could do. Now, what's really nice is that you have this is new, where they might not have this feature later on, but it shows you what's here, so you know we have a VPC. By default, it looks like it created us a route table. So we got that by default, but there are no other resources. There's no internet gateway. There's no subnets. So we will have to go create those ourselves. But it's interesting to see that we did get a default table. So when creating a new VPC in AWS, what other resources does it create? And here it says, when you create, it creates several resources to help you understand. Okay, but without using the wizard. Okay. Yeah, and so it's not really answering what I want, but my point is that when you create a VPC, you're going to get probably some additional resources. And in here, it looks like what it's created for us is a, not this one, that's the default. But we'll go back over to, whoops, refresh here. But you'll notice here our 10.0.0.16, it looks like it created for us a route table. At least that's what it looks like. If we go over here, it might be routing to the default one. And so we go over here, and you'll notice here that there's this one here, and I did not create that one, but this is its main yes and yes. So I mean, wouldn't these be the new ones? RTNAT Crutter. Oh, that's from another time. We'll delete these out so we don't get confused. So maybe what it's doing is it's using the default route table. That's probably what it's doing. I think that's what it's doing. No, it looks like it actually made one for it. So I don't think this one existed before. So what I'm going to do is I'm going to go back over here to CloudFormation, and we're going to tear that down. And, you know, we can tear it down with a command, but I'd rather just do it in the console. That's usually how I do it. And we'll go back over here and we'll see if this route still exists. So notice that route vanished. So when you create a VPC, just a VPC, it will create a default route table for you. And that's fine. That's something I think that we wouldn't mind having. I didn't see what was in it, but one thing that I want to do is I want to make sure that we name our VPC here. So what I want to do is go over to ChatGPT, because it's going to be in the tags, but write a CloudFormation template that creates a VPC named Crutter VPC. And it's probably going to give me more than I want. There we go. So that's all it is. We have our tags just as such. And it did 10.0.0.16, which was perfect. So we'll go back over here, and we will go down below here, and we'll paste this in. And so now that will name our VPC as Crutter VPC. Okay. And so I think that is useful to have. We need to create an internet gateway. So I'll go back over here. Again, we can go ask ChatGPT. So we'll go over to ChatGPT. So create a CFN that, or write a CFN file that creates an AWS IGW, Internet Gateway. It should know what that means. And so that pretty much looks like what we'd want. But we'll go and keep looking it up via Google so that you learn how to get used to looking at it this way. And we could probably find it on the left-hand side here, but I'm going to go and say CFN IGW AWS. And so we'll have Internet Gateway. And if we scroll on down, we'll look at its properties, and its properties are type, and that's it. So there's no, it's just the tag. So if we go back over to ChatGPT, that's exactly what we want is this. So I'll go back over here into our template, and we will go and paste this in next. And so I'll go and paste that in. And so they say my IGW. I'm just going to say IGW to keep it simple. And so we now have this resource, and we want to name this Crutter IGW. Okay. So that one looks good to me. Now, when you create an internet gateway, it's not going to be automatically attached. You have to attach it. We kind of noticed that when we were around here that we saw that there was an attach. So we'll go over here and take a look at that. And so it says type VPC gateway attached. We'll look at the properties. So we have to specify the internet gateway ID. We need to specify the VPC ID. And then there is the VPC ID. So there are 3 values here. Let's go down to examples, to the YAML one. So we don't want to do a VPN. We're doing an internet gateway. So really I think what it's saying here is that there are 3 properties, and you're either going to provide it to a VPC or you're going to provide it to a VPN. And we're only doing a VPC today. VPN is a virtual private network. It's not what we want to do. It's for secure connections, probably out to people's offices or data centers. So I'm going to grab the first one because this is attaching an internet gateway to a VPC. Okay, and we'll go back over here to our code here. And so notice, like, even when I defined this, I forgot that that component was there. So just to show, like, you can write things out and not be aware that they are there. And so we will bring this down here. And so this is attached gateway seems fine to me. And so we need to reference the VPC and we need to reference the internet gateway. So I called this one VPC here, and then this one was called IGW. And so that is one way you can do reference. Another way probably is just doing this. Okay. And I just want to explain what's going on here. So remember that JSON and like YAML is actually valid JSON. It compiles out to JSON. And so if you look at this, this is what it's producing. It's going properties, it's going VPC ID, and then it's going ref, and then it's giving the value as VPC. And so this is what this is here, right? And this is the same syntax. And the thing is that there's all these convenience functions in CloudFormation where you can do like a exclamation followed by its function name and then its parameter. And this is just so that you can make it more concise in one line. So you could literally do this. You could literally do this, or you could do that. And so this one is the most concise and the most idiomatic. But if you ever find that you can't figure something out, you can always just write JSON inline and it will absolutely work. That's how I work around some of my issues. But now with ChatGPT, you can pretty much just ask it and it will solve it for you. So I believe that this is what we want to do. And if you're wondering like where these functions come from, so like if we go to back to our VPC, we have to go back a step here to VPC. Keep going back. Keep going back. Keep going back here. And so here on the VPC page, if you go to return values, it says ref, and so that's the function that we're using. It says when you pass the logical ID of this resource to the intrinsic ref function, it returns the ID of the VPC. And so that's what this thing wants. It wants the ID of it. And just so you know, it's not consistent through services. You always have to look up and see what it wants, because sometimes it wants the ARN, sometimes it wants the ID, sometimes ref will return an ARN or ID or a name. And there are other functions you can use, like function get attrib, which will get very specific functions. And then those things might not be available. So you have to really know what you're doing there. But anyway, so we have the IGW attached gateway. And so that is one component. I just want to keep going here. I don't want to run it every single step because CloudFormation takes time to do. But now let's take a look at making some route tables. So we're just typing in AWS route tables. And so we have routes and route tables because we're going to have connections in between them, right? So we'll go down to examples, and here's an example. We'll go ahead and grab it. We'll go here, and we only need one route table. So we'll go here, and we'll go down below. And I'll just say route table. I like to keep these simple. And this we could say attach internet gateway. I'm going to do IGW. I kind of prefer that because you see we have to reference these later, and these names actually matter because you have a limit to how long you can write them. So trying making them concise is important. And so here it wants the VPC, so we'll just do ref VPC, and then I like naming them. I'm not sure. This is tags production. That's not exactly what I want, but I'll just take that out for now. Some of these have names, some of these don't. So like this route table, we might not be able to name it. Let's go over to our route tables. We can name them. So we'll go back over here. And pretty much anytime you want to name stuff, it's generally this way through the tags. Not always. Sometimes they have their own, so you can't always just copy paste and do that. But I'm going to say Crutter RT for route table. That's the short form I like to use for route tables for AWS. And so we have a route table. Now a route table has to have routes. So let's go take a look at routes. Again, we should always look at what properties we have here, but you can see it says VPC and tags. So not much going on here. We'll go and check out routes. And so down below, we'll go to our examples and we have my route. And so this is a route to the gateway to the internet. And then we have, we'll need a route to local. We always need two routes. So I'll go ahead and copy this route here. Back over. And we'll go here. And it might be a lot of stuff looking here, but we can also just define what resources are in here. So we can say VPC, internet gateway. Well, we'll go back and document that later, but we have our route table ID. So question is, what does this return? What I like to do so I can quickly find these later on is I will actually go and grab the links up here, and then I'll paste them in here so I can quickly find them. So I'll do that a lot, and that makes my life a lot easier. I think we can click through. See, it says control click. Pull control click. I then can click through and open those and find the relevant documentation. So that one is for routes. But let's just go grab them so that we don't have to find them later down the road. Okay, so I'll paste this in here as well. Okay, and then we can go up to our internet gateway. Also, if you know what these names are, you can search these as well. And this is very useful for finding the documentation to the relevant page. So I'm going to just keep going here and adding my documentation. And we also have the VPC here. Okay, and we'll go down below here. So we have one route. And so this route is just for gateway to the internet. That's depends on this. So this is going to be dependent on probably this, the attached IGW. I think that's what it's saying here. Depends on means like this thing has to exist. So this needs to be deployed. The attached IGW has to be deployed before you create the route, because if it does, it will error out and being like, hey, we don't have this thing. AWS is normally pretty smart about knowing to deploy the right things, but in some cases, you'll run into edge cases where it will complain. Now, in the example, it shows the depends on. Do we have to put that in here? We might not. We'd have to just run it and find out. So this might be superfluous, but it is explicit, and so it's not a bad idea to have it in there. But we want to look at the route table because we need to know what it returns, how to get back the ID. So I'm going to click into here, and we'll go down to return values. It says the ref returns the logical ID. And here it wants the logical ID, so that's what we'll do. So we'll go here and we'll say ref, route table. Then we have our destination CIDR block, so that is correct. We want that to go out to the internet, so we'll just leave that hard-coded, that's fine. We have our gateway ID, so we can go up to here and double check our return values. That's what we're always looking for. It says the logical ID, so we'll go back down here, and you eventually figure it out over time. Sometimes you'll just, you'll just assume that it does, and if it fails, it's not a big deal at this stage. But you can see it's not really that hard to write CloudFormation. So we'll go here, and I'll bring these up together because this is a bit nicer, and this should be like that. Great. And it looks like the indentation's wrong here. I'm just going to see if I can fix that. There we go. That is better. So yeah, so now we have a route. So route to IGW. And then we need route to local. So I'll just copy this content here because we need it to route to the entire CIDR block for the actual VPC so that it can actually reach out to the internet. And so here, what I believe that we would be doing is we would be placing whatever that one is up there, which is 10.0.0.016. And so here we aren't referencing a gateway ID. In fact, I don't know if we have to reference anything, but what we'll do is we'll go check the route documentation and see what options it wants. So here it says destination and then gateway ID. I think that's only in the case that you are specifying a gateway. In all other cases, I think it's just you give it a destination block. So if we go down to examples here. Yeah, so that looks fine to me. So now what we'll do is review this, and it looks good. We don't have our subnets yet, so that might be the next thing we want. I want to check if these routes have names. So we'll go back over to here, and we'll go to our routes. And notice that they don't have names. Now, this one actually has a target to the VPC, which is kind of interesting. This one says local. So I guess the question is like, this is the internet gateway right here. This is doing something else here, which is fine. This is for our specific VPC or DDB creditor. That's fine. Okay. These are just because The reason you wouldn't normally see this one here. I added this one in because of what I was doing prior. But here, this says local as the target, but the destination is that. So I'm thinking that, well, okay, hold on. Let's go back here. Was there no target for the route? If we go here, internet gateway, syntax, that's route table, route. Oh, did we link the wrong one? Let me go back over here. Maybe that was my confusion. Let's go here, paste. Oh yeah, this is definitely, well, it's not that big of a deal. And I'm just gonna take that out. I wanna make sure that is clean. I must have just clicked on the wrong one because we can see there's definitely more options. So we go down below. Yeah, there's way more options. So we have instance ID, we have local gateway, NAT gateway, network interface, a lot of options. I didn't realize we could do all that kind of stuff. You know, it kind of also helps to click around when you're doing this as well in the AWS console. So you can kind of see where you can map options to the API and back and forth. But if we go here and we edit the routes, we can see like we have this, we have all these options. And so we want to choose local as our option. I just know that from the past here. And so that's what I'm looking for is the local option. So we'll go down to examples and maybe we'll see something for local. Gateway ID, route table ID. I think what we'd have to do, oh, it says local gateway interface, the ID of the local gateway. Yeah, so I'm not 100% sure what I'm supposed to specify here. Local gateway ID. If we go back over to this, there's local, but local gateway ID. So now I'm not 100% sure. So write a CFN file that routes to the to local for 10.0.0.0/16. And so here it says gateway ID local. So let's go see if that's actually true. Again, we shouldn't just take its word for it. We should always double check because sometimes it lies. And we go here and says the ID of an internet gateway or virtual private gateway attached to your VPC. Okay, so then what is local gateway ID versus gateway? What is versus gateway ID for routes in AWS? This is a gateway that is attached to your VPC and is used to route traffic to other resources within your VPC. You use local gateway value to specify that you want to route traffic to a resource within your VPC. This is a gateway that is used to route traffic to the internet. You can use the gateway ID value to specify the route that you want. When you create a route in a route table in AWS, you need to specify a destination. So that's what I'm not 100% sure on what it's trying to do here. I would think that what we actually want is the local gateway ID. But we do see that it is specifying this, so I'm not 100% sure. So what I'm going to do is I'm going to grab this and see if this works. It might not actually work, but we will give it a go anyway, okay? And we will paste this here as such. And what we'll do is we'll go ahead and try to deploy our template. We'll see if we get any errors. And it's uploading the template. And what we'll do is we'll go back over to here into CloudFormation, and we will go to Stacks here, and we'll click into this one. Because remember, it's always in review. We're always going to have to confirm it. And we can click into it and see what it's going to add. So it doesn't seem like it's going to complain so far. We're going to execute it, and we're going to see if this complains. So I'll see you back here in a moment. Okay, great. So we have a failure. It says the route identified 10.0.0.16 already exists. So when it went and it attempted to create this, we ran into this error. This is kind of interesting because we created, oh, it says route to local. Oh, maybe the logical ID is the same and that's what it's complaining about. So if we go back over here, I don't think we have to delete the stack. Let me see here. rollback in progress. So we will let that roll back, and when that is done, we'll go fix that. But I think it's because we have... No, these are actually different names. Interesting. And this one's actually not dependent on the IGW. And so we'll go back over here and refresh this. We'll click back into it. And so it says, the following resources failed to create route to local, route to IGW. The route identified by 10.00.16 already exists. So it's possible that it's already creating the route for us, and that's the problem. And so maybe we don't need to create the route. Maybe it will already create it for us. So what I'm going to do is I'm going to go back here, and I'm just going to comment this out. Whoops. And once this is done, rolling back, we can go ahead and delete the stack because you can't redeploy on a rollback to complete for a new stack. That's just how it is. If this was deployed and it partially, like it worked, then we wouldn't have to delete every time, but in this case we do. So we'll go back over here and we will attempt a new deploy. And so remember, it's going to upload the file to S3. Then over in CloudFormation, it's going to show up here. We're going to go to the change sets. We're going to check it. We're going to see what it does, and we're going to execute the change. And then we will see it when it's done, okay? All right, so we are back. It looks like this is done. If we go here, we see create completed stack. I'm going to go to the resources here tab, and let's go take a look at what we can see. So we go over here, because I'm really interested in that route table. And we see the VPC. That is great. We can see it has a main route table, which is fine. It also comes with a network, a NACL. And so just be aware that it does create a NACL by default. I think the inbound rules are, yeah, so it has an allow for everything there and an outbound there. If you're ever running into, I'm telling you this as like help if you ever have to debug networking issues or you have to take like an online challenge about like AWS networking. But NACLs are just kind of forgotten about, but these things will block everything for specific IP addresses where security groups are blocking for a range. So I would just say that if you're ever running into networking issues, make sure that your NACLs actually have outbound routes because that could, if that's not there, then it would deny everything on that rule there. But anyway, what we'll do is go back to our VPC, and I want to go take a look at our resource map, which is, this might not be here in the future, but we have it for now. And you'll notice over here we have a route table and we have a network connection. It's not showing a line between them, which is kind of annoying, but what we'll do is go over to our route tables here. And we will checkbox this on and we'll go to our routes. And you'll see this already has one to 10.0.0.0.16. And so maybe it wasn't letting us do this because we were creating one that was in the same route, right? Because it's saying like, hey, you can't have another one here for some reason. So that's at least what I think. But what we'll do is we'll go here and just say like, create a CloudFormation template for a VPC attached to a IGW with a route table that allows the VPC to reach the internet. And we'll see what it generates out. So we have the VPC, we have the internet gateway, we have the attachment here, and it is making a route table. And here it has a route table from here. We don't see a route for local, which is interesting. But we do have the My Subnet Route Table Association. Okay, so that's definitely something that we missed. So let's go take a look at this. Maybe that's the missing thing. Because maybe when we associate it, we'll automatically create that local one, and then we don't have to do that. So I'm going to go ahead and grab this reference here. And, well, I'll grab the code first, I suppose, down below. Thank goodness for ChatGPT, because that would take forever to look up. I mean, maybe not, but, you know, it usually becomes a headache. So I'll paste this in here, and this will be my subnet route table. So, well, this is association for the subnet. It's not necessarily for the route table to the VPC. So actually, I'm a little bit confused about that. We'll go down here, and we'll uncomment our route table, and maybe our IGW. And what we'll leave here is our route to local out, because that's where it was having an issue. And we'll go ahead and we'll try to create this again. I'm not deleting and redoing it. I'm just going to see if it can do it in place. It might not be able to do it, but we'll see. And this is kind of how you learn about what will work and what won't work. So change set has been created. We'll go back over to CloudFormation. We'll click into it. It says add an add. There is no replacement, but it's going to create a route table and a route. And we'll go ahead and execute that change set. And so we'll go over to our events. We'll refresh. You can see the route table is being created. Remember to refresh constantly, because it's not just going to magically appear for you. You have to hit the refresh button once in a while. And then it says complete. If you want to know it's really complete, you go over here. You can also refresh here and just wait for it to be successful or finished. Sometimes these events will be done, and this will still say update in progress because there is a bit of a delay between that communication and the end process. Here it's creating that route to IGW, and now the update is complete. Let's go back over to our routes tables. We'll refresh here. Notice we have a third table called Crutter RT. It is not the main table, which is kind of annoying. I really would like to make the main table in the file here, but we go over here and we can see that we have in our routes here, but it's also routing out to 10.0.0.16. So, you know, how do you create the main table for a VPC in CloudFormation? When you use CloudFormation to create the VPC, it doesn't recognize the main table route that's created by there by default. Therefore, information about the route table can't be passed through VPC in CloudFormation. As a result, you can't add or remove routes. Okay, so that's kind of what we're looking at here. The data, the custom resource, well, how does this help us? Oh, resolution. If you receive errors, make sure you're using the most recent version of AWS CLI. Yeah, it's not really what I want. So we'll go back here. How do I refer to the main route table that is created when VPC is created in a CloudFormation template? You have your Internet Gateway route table. You need to create a route and attach the route table to the subnet if you haven't already, if you're doing so with the YAML template. But I want it to be the main table. Route table. It's not really what I want. But anyway, at least we know that this is being set. So when we go back over here, we know that we don't need this route because it's already being created for us. And that kind of makes sense when we couldn't find the local part there. But I'm still surprised, like, how do you set the main route table? And you'd think I'd know this, but I'm not setting up these all the time. You set them up once and you kind of forget them. But notice there's like no option for main. The following examples uses the VPC ID from a VPC. The other thing that we could look at if we're trying to find it is we could click through here and maybe we could reference the main route table through here. So if we were to go down to return values, the association ID for the CIDR block, the default security group, the default NACL. So I thought there might be a default route table. So, you know, I'm not 100, I don't like the fact that we have like a floating table there. But can we set the main routes tables in here? See, this is where Duan would have been super useful, but you know, at the time, you know, I just didn't have a networking week and I'm just kind of squeezing it now. So if we go over here, set as main route table. Set main route table in CloudFormation. Let's ask ChatGPT. How do I set the main route table in CloudFormation? Oh, main route table ID. Okay, so maybe we just didn't notice that from before. And that's why you have to thoroughly read all the documentation. I am instructing while doing this, so it's understandable why I might have missed it. But we'll go back over here. We'll click in through here. And if we go down below here, main route table ID. We are in VPC. And it shows it right there. If you want to modify the main route table or associate a different route table, you can use the main route table ID property. Okay, where is it? Am I crazy? Where is it getting this value? How do I get the main route table ID by the subnet? Another thing we could do is we could check the AWS CLI for this. Because I'm trying to understand, like, is this an apparition that is being generated with ChatGPT, or is it a feature there? So if we go here, I'm looking for the main route table. Route table. Another place that it could get set is in the tags, but I don't think that's what's happening here. Because notice this isn't under tag, so it just has this here. I don't think that's actually a feature that exists. I think it's making it up. So, you know, again, that's the issue here, is that ChatGPT is trying to figure it out, and it's making stuff up for things that aren't true. So I guess for the time being, we're just going to have the additional main route table. If there's a way that we can get rid of it, I'd love to know how. But right now, we'll have to live with what we got. But it's nice that we have at least this named here. We'll say set main route table for VPC. AWS CLI. Or we can say associate main route table for VPC AWS CLI. Associate route table. Is there any main option here? See, I don't have a main option. So however that's happening, I have no idea. But we do have this additional one here. Maybe I can talk to Baco about it and see what we can do. But anyway, what we do want to do is associate some subnets, but we will need to create some subnets. So let's go back over to our CloudFormation template, which is over here. And we'll go down below. And we'll go ahead and start creating those. So the first one I want here is subnet A, subnet B, subnet C. Okay, those are going to be the three that I want to have. And if we want to be explicit, we can say pub for public, because we don't really need any private subnets. I'm just thinking about that for a second. I don't know if we need any, but just in case we do in our future architecture, I'm just going to go and do private, because the thing is that we do have our database, and our database might want to sit in a private subnet. So we'll have to decide about that. I'm going to just make them anyway, just in case we need them. And so over here we have our subnet. So go ahead and grab that. And our type here is going to be AWS EC2, probably EC2 subnet. I don't know, I'm just guessing, yep. And we can see we have a lot of options. We'll go down to our example, grab something to begin with, and then we'll read through those lines. Okay, so the first thing, we definitely going to have a, well, we'll actually read through it and see what's what first. So I'll just bring that over here for a second. We'll go to the syntax. And so we'll walk through the first one. Assign IPv6 on creation. Indicate whether the network interface created in the subnet receives an IPv6 address. The default is false. I'm not comfortable with IPv6 yet. I generally turn this off. Sometimes there's things where you can't easily turn them back on later on. So this could be a thing where we might want to have it turned on, but I just don't know for certain. So I'm just going to have it explicitly off based on the example that they have there. We'll go to the next one, the AZ. So the availability zone of the subnet. If you update this property, you must also update the CIDR block. And so it's not required, but I'm going to set it because I want to know exactly which one we're using. We have it down here below. The next thing might be the CIDR block. Availability zone of the subnet. The AZ ID of the subnet. Wiser 2. the the availability zone of the subnet, the availability zone ID. Okay. Is it one or the other? You must also update CIDR block property. I'm not sure why there's both, but we know we need the CIDR block subnet or CIDR block for the subnet. Enable DNS64 indicates whether DNS queries made to Amazon provider DNS resolver in the subnet should return a synthetic IPv6 for IPv only for destinations. I mean, that sounds really cool, but I don't think we need that right now. We don't need IPv6 for anything. So I'm just going to say false. Because again, I'm not amazing at networking. Only if you need IPv6, which we don't need. We don't need IPv6. Map public IP on launch. That's how you know that this is a public subnet or not, is this feature right here. And so, you know, public subnet. I'm going to strongly indicate that so we know. This is default by false, but we actually want it true. Outposts RN. We're not using outposts. That's for like AWS racks that sit in your data center, very expensive service. Private DNS options on launch. The hostname type of the EC2 instances launch into the subnet and how DNS-A and AAA, that's IPv6, I believe, queries to an instance should be handled. I don't know. It says it's not required. I don't know, so I'm going to leave that alone. Then we have our tags, and so then we have our VPC. So we'll go here, and this will just be ref VPC. And we definitely want to name these subnets. I'm pretty sure you can name them, and it's going to follow this pattern here. So we'll go down below here, and I'll paste that in here, and this will be Quadr sub. Well, I called them pub sub at the top there. Sub net pub A. I'm going to switch it over to this pattern instead. Subnet pub A. This needs to be commented out. We'll take that out here. Oh, I wrote it wrong. It's supposed to have doubles in between. There we go. And so, yeah, there's our Quadr subnet pub A. And this is going to look very similar, but we're going to go ahead and copy and paste this 3 times. So this is where, you know, if you're using Terraform or CDK, you could iterate through this stuff and it wouldn't be so repetitive. And so that's something that you could do that would be really nice, but that's not something we are doing here. Okay, and so then we have our private. So our private is going to just be false here. That's the only difference. And this will be called priv instead of, or PRI for private. PRI. I kind of want to call it priv because then it's just easier to read. Then I know it's private. PRI is a bit cryptic. And we'll go here and grab the next one. And we'll go here and grab the next one. This one needs to be called, that one already is supposed to be C. This one is B. And they're already false. So the next thing is we need to get the CIDR block ranges correct. So we have 10.0.024. Let's just go look at AWS's for an example. I'm terrible at this. Again, I've done it in my course, but it's not active memory I keep in my head. I'm not that kind of wizard. So they're doing /20, and then it says 0, 16, 32. So you can see the increments are in numbers of 16. So I'll go over to CIDR XYZ here. And what we can do is look at what 20 gives us. 20 gives us 4,000 per. And so we have 16, 24. So what I'm going to do is I'm going to go over here and say write CIDR blocks for 6. Okay, so for a VPC at 10.0.0.016, split this into 6 CIDR blocks. For 6 subnets. For AWS, return enable pointed list. Let's see if it's smart enough to do that. Okay, and so here it's saying 24, and so it goes, we have 24, 1, 2, 3, 4, 5. And just understand that depending on what this range is, you have to change how this value increments. So we can go back over here. Let's just double check what 24 gives us. That doesn't give us a lot. That is a bad splitting. No. Please evenly split the maximum IP addresses. And I can hear a bird. I keep thinking there's one stuck in my shed. Baker was having this problem the other day. And so here it says 22. So what does 22 give us? 22, 1,000, 24, 22, 20. Is that smaller? Did that number get smaller on us here? Let's go back over here. This one's 22. This one is 24. So 24 is, oh yeah, 24 is not good. 20. Well, how much does 16 give us? It gives us this many. So if I go here and I divide this by 6, we have enough room for 10,000, right? And so we go here, and so 22 is this, 20. Why isn't it not giving me what I want? 19? Oh boy. We'll go back over here because again, it's going to be based on what you have available. So, I think 22 is okay, but just understand, like, that's how many we're going to have. So we're going to be limited to 1,000 services in an availability zone. So if you wanted to have one in each one, up to that, that's how many we have. And so if we ended up having more, we'd have to rework that stuff based on the available IP addresses. So that thing is kind of very important. But again, it just depends if we're going to end up using those private IP addresses. So I'm just trying to think about this here. Because if we launch our instance in a private subnet, if we don't have internet access, then we can't shell easily into it. We'd have to use something like an intermediate way, like a VPN, or we'd have to launch Cloud Shell or other stuff to interact with our production database. Now, it is best practices to put your database in private subnets, but for our purposes, it becomes quite the headache to debug it if we run into issues. So I think that I'm going to stick with 22. Again, I am not good at networking, but I'm good enough to get the job done. So we'll go back over here and we'll see what we got. So we have, I do like this is easier. So this one's 10, 22. And so this one would be that, then it's 4, 8, 12. So it's going up in increments in 4. And there's math behind it. I'm not going to get into it because I don't know it too well. But we'll go here and this one's fine. So the next one is going to be, what they say, 4, and it's on the second number here. So this one is 4, and then this one is 8. Whoops, sorry, wrong number. This one is 4. This one is 8. The next one's going to be 16. The next one's going to be 32. The next one is going to be, oh, is that right? Am I going the right numbers here? 16. Let me double check here. Oh, 16, 20. Sorry. I started thinking in larger increments. So we have 16, 20, and then we'd have 24. And you can kind of see how this file gets really large. There are ways of making these files more manageable. You could, if CloudFormation obviously, or CDK is code, so it makes it a lot easier. But you could break them up into separate files and then tell it to stitch the file and then run it. And so I have done that in the past, but it's not that big of a deal. So yeah, that looks fine to me. And now we have our subnets, but these subnets, they're associated with the VPC ID, but they're not explicitly associated with subnets. And so that's something that we're going to want to do. The other thing is that we didn't say what availability zones they are in. So we'll go look for what mine is. There are different subnets for different regions. So we'll say here, we'll go over to ChatGPT because I don't want to look for it. So list in a bullet point, list out the AZs for CA Central 1. Okay, so notice it's 1A, 1B, 1D. There is a conspiracy. What happened to 1C? It's haunted. A fire broke out. You know, I don't know. But the point is that it's A, B, and D. It's not A, B, and C. For your region, you'll have to look it up. And so we'll take these values. Right now, we're placing these in. We're hard coding them in, but we will go and swap them out here in a moment. And you know what? It does end up to be a little bit larger file, but at the end of the day, it is also very easy to maintain these files. So just try not to think about your own personal optimization. Think about the long-term maintenance of this file and how convenient it is to have it as simple as possible. So that is for that one. We'll go ahead and do it for the next ones. So this will be for A. This one will be for B. And this one will be for C. Now the thing is that we have the names here like A, B, C, but they don't actually map exactly because the last one goes to D, right? And so instead of using letters, I think I'm going to switch over to numbers because I'm already seeing that, you know, I don't want people to think that that associates with that specific subnet. So I'll go here and just change it as such here. Okay. And we'll have to do the same thing for these ones. So we'll go here and I'll say 1, 2, 3. And we'll say 1, 2, 3. Okay. All right. So now what we can do is also explicitly associate them. So before we do that, there is a associate, I believe, somewhere here. Subnet route table association, subnet ACL association. We just want to do route table here. And there's not that many options, it looks like. It looks like there's just a couple. And so we'll grab this. And we'll just explicitly map those. So this will be what all these are. So we have okay. I know I need one for 2 and or 1 and 2. And then we go here and we'll go pub. And now the thing is that if you're using JSON, the nice part is that you could condense these into single lines, and that's one advantage like that you have. So just understand that we can compress these a bit. I'm going to go here and say ref. I don't know what the subnets return, so we'll go back up here. We linked this. I'll grab it for all of them, so it just saves me some trouble here. Two, 3, and we'll go ahead and open that up. We will scroll on down here. And oh, I want to see what the return values are. So this returns the logical ID. I think that's exactly what we need. Sometimes it needs something else, like sometimes it needs the name. But here, yeah, this will be ref, and then it'll be whatever it is. So PRI subnet 3 is what this one's called right here. Okay, and then for the route table, this one's going to be whatever a route table is. We called it route table, I believe. Okay. And so you can see this is pretty darn short. You know, I'm just deciding whether we want to do some inline JSON for fun. No, I'll just copy paste it. It's not really that bad. So we'll go here, and so that's for that one. We'll go up here. This one will be 2. We'll go to this one. This will be 1. Didn't we change it to be subnet pry one? Oh, we didn't change it for those ones, did we? Yeah, so we'll go here. Sorry. I want this one to be subnet priv. Subnet. Oh, sorry. Is that... Oh, I only changed it for that one. Okay, sorry. So this one's going to be subnet prub. This is kind of where the headache is with CloudFormation. When you have a lot of files like this, then it kind of becomes hard. But for the scope of what we're doing, it's totally fine. So that one is good. Subnet priv. Subnet priv. Subnet priv. And yeah, so these should be really pub like that. This is supposed to be priv. Okay, and so this one's going to be subnet priv. Same thing with this one. Try to get your naming right as best you can, okay? All right, so now I think that's correct, and we'll go here and we'll copy this one. This one will be pub. This one will be pub. This is pub 3. This is pub 2. And then we have pub 1. Okay, so yeah, there we go. Let's go ahead and do a network deploy. And it's complaining about don't hard code the value in. So these are warnings. We're not going to hard code them. We're just doing them for now. But it says reference pub subnet 3 not found as a resource or parameter. So that's just because we named one wrong. So go here and say pry subnet priv here. There's probably just that last one that was messed up. And so what's happening is that the CLI tool, the linter, these are not errors, these are warnings. And saying, don't do this, it's not good practice. And so it's refusing to upload our code, which is annoying. So what we can do, and I mean, I was gonna do this anyway, but I guess we'll do it now, is we'll go ahead and do some parameters. So we'll go up here and we'll just say parameters. Now with CloudFormation, there are parameters, CFN. There are some, like, you can pass strings, but sometimes they already have some predefined ones, AWS-specific parameters here. And so I'm just looking for ones like AWS, yeah, so they do have one for here. And so I want this to be the type, so I'll go back over here. And so for parameters, parameters, I'm gonna paste that in and say type. I believe that's what it'll be. And then the value, which might be the default value, might be called default. So we'll go back over here. I just want to see some examples. Type, yeah, default, allowed values. So I'll go back here. I'll just say default. This will be CA central 1. We need to name this parameter. So this will be AZ1, AZ2, AZ3. And the thing is that, you know, we could pass these and override them, but I'm setting these as the default so that I don't have to worry about them later. The default wouldn't be CA Central 1, it'd be whatever it is, A, B, and then D, right? And then we can reference these parameters above. So I think to reference parameters is just, we can use ref again. So what we'll do is go into priv1, and this will be ref. We'll scroll up on the right-hand side here so we can see what we're doing. This one's going to be AZ1, okay? And then we'll just keep doing that. So for the next one here, ref AZ2, ref AZ3, And then, oh, we did the private ones. Okay, that's fine. We'll do the public ones as well. So ref AZ1. But yeah, you get used to it after a while. So like it can be jarring to work with this much YAML, but you get used to it. And that's, I think, the thing is that if you can just get used to it and then you get the benefits of it, why would you use something more complicated? But you can see, like, if you had a larger project and you're managing stuff, then CDK would definitely make sense because you don't want to be doing all of this manually. It might have also solved the issue that we had with the main table. Maybe there's some way that we can use code to set the main table afterwards and maintain it if there's limitations for CloudFormation. But we'll figure that out as we go. So now we have those set. I'm hoping that this is going to complain less. And so it looks like it's going to create that change set. We'll go back over here. We're going to go into our change sets. We'll take a look here. And notice that it says add all these things. So that looks good to me. Nothing's being replaced because they're new. We'll execute the change set. We'll go ahead and do that. So, you know, it might be possible that we could create the private subnets and then update them after the fact. But again, I don't know if we need them. We can always retroactively go back and remove them out of our architecture if we don't need them. And it's already failed. We'll take a look here. The following resources failed. Resource handler returned invalid request property. IPv6 CIDR block cannot be empty. What are you talking about? Of course it can. Let's go back here and take a look to the subnet here. And so it's saying here, if you assign IPv6 on creation, you must also specify this. Didn't I set this to false? The default value is false. We'll go back over here. Okay, well, I definitely set it to false. You must also specify IPv. All right, so even though this value is false, it's still expecting it to be there. And so that's kind of a weird thing. So what I'm going to do is make it happy by just removing it. But the thing is that because it's set to false, we shouldn't have to, you know what I mean? We should not have to go ahead and do that. So we'll go ahead and save that. It's so silly. But notice that because we, this is now update, rollback, complete, cleanup in progress. We don't need to delete this stack. It's not like it got rid of the stack. But what we can do is go ahead and hit up and then deploy. We didn't have to delete it, even though it's in a failed state. And we'll go ahead and attempt these deploys again. So hopefully that is clear what I'm saying there. Where's my change set? Oh, it's in progress, so it's not done cleaning up. We'll wait here for a bit. All right, so I'd wait a little bit there. And so we're back here. And that's why when I'm writing CloudFormation, I try to write as much up and see what stuff fails, because it can be tedious to do this back and forth, but that's just how it works. So we'll go back and attempt to deploy this again. It's creating that change set. We'll go back over here. We'll go to our change sets. We'll click into here, see that it's adding all these things. We'll go ahead and execute the change set. We'll click that. And we will refresh here, and it will go ahead and start creating these resources. We'll go over to our resources here, and is it done? No problem yet. We'll just wait a moment. Update complete, cleanup in progress. So it sounds like it was successful. Update complete, that is great. Let's go check out some of our resources. I'm just going to close a few other of these tabs here because it's getting a little bit messy. We'll go over to resources. I want to click through, or at least open up our VPCs here. So go to VPCs. And we have our creditor VPC. We can go here, look at the resource map, which I really like this view. I hope they keep it up here. And we can see CA Central 1A, B, D, they all are associated, explicitly associated with our route table down here. We have this one here. I don't know what to do about it. I think it's just going to be living with us rent-free. This goes out to the internet. So we can exactly see what this looks like. I want to make sure that it's very easy for us to identify what our stuff is. So here we have creditor. We go over here. We can see our subnets here as Crutter, so that is good as well. The internet gateway, we can see that it is Crutter. I'm trying to think if there's anything else here. It comes with a default NACL. We're not going to mess with that. That is totally fine. But yeah, I think that is what we want. So I think we have everything we need set up. Now for security groups, we're not going to do it in this layer. We're going to do it with the appropriate service that we need, because they usually are around particular services and not this broad networking component. You could put them in here, but I don't think that is the best practice. If there are like generic ones, there could be a way to engineer like generic subnets. But again, I'd rather just do that. The only nice advantage of having the subnets defined in this networking layer is it might be easier to reference them as opposed to having to reference a lot of cross-reference stacks. So that could be something that could be considered, but you know, I don't know. I'm just structuring it based on the way that I know how to do it. But anyway, now that we have that, some few other things that we can do here is we have these parameters. So we were able to do that, but we do have our CIDR block, and that's something that we'll also want to, I think, customize and change here. So I'm going to just say like VPC CIDR block here. And something else that might be interesting is to check out what other parameter options we have here that are specified. There might be ones for like CIDR ranges. And this is based on my memory. So we have subnet ID. That's not what I want. Is there one for CIDR? Down over here. There's no specific types, but there are, you can use delimited lists. I don't need delimited lists. Just trying to check here. Oh, you can select ones from that? I don't think I've ever actually done that before. So it says CIDR block select 0 from the block addresses. I've actually never done that. And I kind of like that. So maybe that's something that we should do. That is actually quite nice. So I'll go here. And we could probably also do that for our AZs, eh? So we have subnet IP blocks. I could say CIDR blocks. I prefer that. And then it's a comma delimited list. So of the CIDR blocks for our private and public subnets. And so now what we can do, that's actually quite nice. This will be whatever it is, 10.0.0.24. So we'll go here and we'll say 10.0.0. And we'll take the end off there. I don't think we need to have, we could just take that out because it'll automatically become a string anyway. So we'll do 10.0.0.4.0.24. And then we'll say comma 10.10.0.8.0/24. Then we have 10.0.12. Is that what it is? We have 0, 4, 8. Oh, 16, right. Wait. How did it go from 8 to 16? 0, 4, 8, 9, 10, 11, 12, right? 8. What the heck? Let's go back over here. 0, 4, 8, 12, 16, 12, 13, 14, 15, 16. Okay, that makes sense. Yeah, so maybe I missed one, which is totally fine because we can just correct that there now. So say 0, 24, 0, 4, 8, 12, 10.0.16.0/24. 1, 2, 3, 4, 5. 6. And this would be 20. So we have 0, 1, 2, 3, 4, 5, 6, right? That's 6. 1, 2, 3, 4, 5, 6. There is a way in, because this is all YAML, right? And so in YAML, you can actually turn this into a single line. And so there is like this character and there's this character. I actually have a YAML course that I haven't released yet. I'm going to go look for that formatting because this is where our lives can become a lot easier. The YAML and YQ course, which I really would love to produce this one at some point. There's not that many slides, but it talks about what YAML is. And what I'm looking for in here is there's a particular type of character in here. Wow, I do such good jobs on stuff and then I don't release the courses. Over here, right? So see here, if you do a line, it's going to have new lines. If you do this, it's going to treat it as a single line. So what we'll do is we'll make this a bit easier by doing this, right? And then we bring this down below, then it'll treat it as a separate, like a single string. And so it looks like it does put a space in between them, which is what we do want. So we'll go ahead and do that. And so this is where we're getting kind of advanced with YAML, but you know, it's not too hard to learn once you figure that out. And that's why I should really release my that course there. But we now can see this. So we have 1, 2, 3, 4, 5, 6. Let's make sure we have the commas on the end there. We'll need them. And the last one does not need one. I think we could also do the same thing for the AZs. So we'll just say availability zones. And I mean, it does say AWS EC2 availability zone name. And we can do that, but I think what I'd like to do is just bring it in like this way because it's just easier to access this way and for us to change it, even though it's nice because this will provide formatting to say, is this of the correct format of the resource, which will help with error handling. No, we can just leave those in alone because it's nice that we have that, but we don't really have like this checking what format these are in. So now we'll go down below here and we'll take a look at our parameters here. And there is a way that we can reference these. So it's using this select thing here. So we'll go ahead and grab that. And I'll go back over here. And we'll go up to our subnets up here into subnet pub 1. And we'll go ahead and replace this like this. And I forgot what the name was that we called it. So I'll go all the way to the top here. And we'll grab the subnet IP blocks, CIDR blocks. And I guess we can make it a bit nicer and call it like that, if that's how they call it there. Paste. And yeah, you'll see me changing names constantly like this because I'm just trying to get them the way that I like them. And so this is the first one. It's unfortunate. Well, this one starts at 1. But that's totally fine. We know that we're offset by 1. And so we'll go to the next one here. And this one will be as 1, which is actually 2. And then we'll go to the next one. And this one will be our third one. And then we'll go to our next one. And that will be our fourth one here. We'll go to our next one here. That will be our fifth one. We'll go to our next one here. That will be our sixth one. Okay. Well, it wouldn't be 6, it'd be 5th, right? There's no 6. 5, 4, I must have missed a number here. 3, 2, 1, 0. Yeah, so I made a slight mistake there, but that's all resolved. Then we need our VPC CIDR block in here. And so we do know that, I'll do it like that. We do know that, what do we know? It doesn't matter. But we'll go here and we'll say default and we'll copy paste this value in here as such. And we'll take out that. We'll just say the type is string because that's all we can say that it is. We'll say type string. Probably is capital. Actually, I don't think the casing matters, to be honest. I think it will take it either way. But yeah, we could end up like doing this, but then we'd lose that validation, which I think is kind of nice. So even though this is a little bit more work, we'll just leave it in as such. I mean, it's not going to save us that much, to be honest. But anyway, so that looks good to me. What other stuff could we put I'm going to take this out here. What other stuff could we put in here? And also the ordering kind of matters. So like, it doesn't really matter, but I would put this up first here. And then the next thing is we would define this. And I don't know, I try to order stuff based on how I think it's associated with different data. But I mean, all these names are hard-coded as well. We could use the stack name to define it. Because in our stack, we do call it credder. There are special, like stack name, CFN, in the parameters here. These are called pseudo parameters. It's in my CloudFormation content. And so over here, we have the stack name. And so we can use this as a reference in order to get that value. So if we want, what we can do is we can use a substitute. So in our tags here, we'll do sub like that. And then we can then put in this. And then I think it's curlies like that. And so that should interpret the name. Now this is for substituting a string, so probably do this so that that doesn't error out. I can't remember if we need a pound on that or not, so I'm not sure if we have an example. So we'll go over to ChatGPT. Use sub with stack name for CFN AWS and see what we get. And today it is not happy, so that is okay. We should not rely on ChatGPT when we can just figure things out by ourselves. Sub interpolation AWS. Interpolation is what that is when you do the curlies. I should go to examples here. I just want to see YAML. Okay, so it has a $ in front, so that's what we're missing. It's using single quotes. It doesn't actually matter if it's single or double because it's YAML that that decides that. And so that could be like a nicer way for us to want to change our names, because if we, let's say we deploy this, then it would change it to like credder prod, you know what I'm saying? Whatever you want it to be. And so, you know, we have these up here, but sometimes these names have restrictions, and so we can't always name them based on the same thing as their logical ID. I don't know if there's really any way to reference the logical ID anyway here. So, you just write it again. But what we'll do is we'll go here and bring in this sub to our other ones. So for this one, this will be IGW. And then for our route table, this will be RT. And then we'll go and just keep looking for names here. And this will be subnet pub 1. And then we'll go to the next one here. This will be subnet pub 2. Subnet pub 3. And then we'll go to the next one here. This will be priv here. And this will be priv 2. This one will be priv 3. Okay, and the rest are fine. So that looks like we got everything that we want in here. Because we're just kind of renaming stuff and not really changing anything, what I want to do is tear down the whole stack and make sure this works. So go to our stack here. We'll go ahead and delete it. Close these tabs up here at the top. Once that's completely deleted, I'll be back here in a second, okay? All right, so that stack is all teared down there. Let's go back over here, deploy. Hopefully we don't have any problems, but it does say, oh, it's not being used. So we have a parameter. And so it's a warning, but it's good that the warning happened because technically it's something we want to do. And so some cases I turn off CFN lint because sometimes it does stuff that I don't want it to do now that I remember working with my CloudFormation templates. But I'm looking for where we define that VPC. So it's over here. And so we just need to do a ref, and I'll paste that in there. And so that's what we want there. There could be other things that we want to uplift into our parameters. You know, like it could be the DNS support. I don't think so. You know, you could lift everything up, but some things are just like, so like IGW goes out to 0.0.0/0. So there's no reason to pull up that parameters, but you could go as crazy as you would like to have overrides. but this is the stuff that I want to have for it. Another thing is that we might want to have some outputs. We don't really need outputs, but we could output some values. Sometimes it's useful, like when you're in CloudFormation, you want to see, so like if you go over here, you want to see those values and also reference those values later on. So that's actually something that we'll probably want to do. But let's go ahead and just see if we can do this deploy. And we'll give it a second there. And so we'll go back over here. Whoops, we'll go back over to our stacks. We'll give this a refresh. And we'll go ahead and see if this creates. Now, what we can do is we can have outputs, but yeah, now I remember is that we'd also need outputs, but we can also mark things to be exported, and that will allow us to cross-reference values, and so that makes stacks dependent on each other. And so that's something that I think that we definitely want to do. Just to show you how outputs work, so CFN outputs. We go over here. Notice here it says outputs logical ID description value export. So you don't have to set an export, but if you do set an export, then we can use that. And so that's something that I definitely want to have. So what I'm going to do is copy this template and I'm going to bring it over to ChatGPT. And of course, if you're working for a company, you can't just copy paste this stuff in. It depends on what it is, but this is generic code. There's nothing special here. And so I really do want to use ChatGPT for this because I really don't feel like typing it out by hand. There we go. And so I'm going to say, take the following CloudFormation template and write outputs for the VPC ID, the VPC IP range, IP CIDR block, the subnet, a delimited list, a comma delimited list. So we'll say take the following CloudFormation and write the outputs for. Oh, frickin' geez. I have to hit space there. So take the following CloudFormation template and write outputs with exports for the following. So we want the VPC ID, the VPC IP CIDR block, a comma delimited list of the CIDR blocks for all the subnets, a comma of the AZ names. And then maybe we'd have like a comma delimited of the subnet IDs. And let's see what it produces. Okay, and so we'll scroll up and I'm going to grab this code here. Okay, and we'll go all the way to the bottom here. And we'll take a look at what it wrote. So here it goes, outputs VPC ID, and it's not using my frickin' names. Okay, so I'll go back here and because there's no my VPC in my thing here. Look, if we go my VPC. So it's not doing it intelligently. Use the correct logical names for the referenced values. Stupid thing. All right, it's not doing it right. That's fine. So we'll go over here, and what we want to reference is the VPC, and that will get us that value. So we can say like, I don't think we need to like prefix it with credder because it will be still reference based on the stack. So we're going to say like VPC ID or VPC ID here. Same thing here. I just want these to be the same name, so it's very easy. This will be VPC. And for here, this will be subnet CIDR blocks. Subnet IDs here. We have our AZs. We could just pass, like we have them, we're selecting the get AZs from here. That's not very useful. We could probably just pass the value, so we could just grab it from above and pass it along. Because this is just joining it as a string. So we'll go up here, and we'll just say subnet CIDR blocks. As such. And then the subnet IDs is a different story. We want to join these. We can bring this down a line here and do a hyphen. And then in here, we can give it a list, because that's all it's doing is providing a list. So this has a list within a list. So notice here, like it's an array, and then there's an array inside of it. So this one's a bit tricky where you have to do this. And then what you need to do is then indent it again and do that, I think. Okay. Or you know what it'll be? It'll be like that. There we go. And so you'll see this, and that's when you have an array inside of an array. You could make it one line if it's more clear for you. I prefer to do it this way. Sometimes you can do this and put it on the next line like this. And sometimes you can't. Sometimes you have to bring it down. That happens a lot when you have like subs and joins inside of each other, which we'll find out as we do this. We don't even have to do double quotations around there, but I'll leave it in because it looks nicer. And so here is where we can reference our subnet IDs. So we'll have to go grab each one. So here is that one. This one's going to be pub1. And we'll go up here. This will be pub2, pub3. But yeah, it's really useful to know YAML syntax so you have more flexibility. For a long time, I didn't know the advanced features of YAML. I was always staring at this stuff, trying to figure it out. It was quite the headache. But you know, you can make these go into single lines, which is nice. We pass all of our AZs as well. A little bit different, but we can probably use the same thing here, a join. So we'll go here, and we'll do hyphen, and then hyphen again, and we'll do ref. This will be AZ1. And then we'll bring on the next line, take out that one. This will be AZ2, AZ3. Okay, because I'm pretty sure we will need these. If we don't, we can, again, go back and fix our templates and fine-tune them till forever, but this is the best way for us to learn. We'll go back over here. Did this fail? Did this succeed? And it was created successfully. So now what I want here is I want to bring in these exports. And so we'll hit enter, see if it complains at all. Ref subnet priv not found. That's fine. We should have a 1 on there. So we'll hit up. So like it doesn't check for like string values, but if it's logical IDs, the linter can do that. So it is a little bit more intelligent than just JSON YAML formatting. Template format error. The value field of the every outputs member must evaluate to a string. For which one is that an issue for though? Because these are joining, right? So ref CIDR blocks. Oh, and so the CIDR blocks here, they are a delimited list. And so we actually have to join them together. So what we can probably do is just do join on this. And it might be smart enough to just join them together. Okay, because the second output here is going to be an array, right? So I think that that's what we can do here. Let's go look at join for its shorter syntax because it's kind of having some trouble here. The YAML's still using squares, so I guess we can do that to make it happy. So I'll go back over to the template here. And we'll do this. And the reason we didn't put this in squares is because this already returns an array up here. This is going to have an array that we can reference. So we'll go back and hit up and see if that makes it happy. join list of values on line 178. Oh, you know what? Because we have to reference it. That's why. Otherwise, it's not going to know how it works. Sometimes these internal, like again, when you use these parameters inside these shapes, sometimes it doesn't know how it's working. You have to finesse them in YAML. If we run into any examples, we'll work through it, okay? We'll go back over here. We have a change set. It's not going to change anything because it's just making outputs. So that's why we didn't see anything in there, but it is going to do something. And it should be pretty quick because it's just outputs. Let's go to our outputs, and now we have these. And so now we can reference these, but I believe when we do cross-reference, it'll have the stack name in front of it, and then the key value. That's why we didn't have to put credder in front of it. Okay? And also, we never really observed the resources and their names. So we can go over here and take a look. Just any of them to see if they have nice names. And so credder, subnet, priv1. So we are getting nice names, which is nice. But yeah, that's pretty much what we wanted to do for our networking layer. Our networking layer is done. What I do want to do is go into Lucid Charts and document what we have. And so maybe that's what we'll do. As we work through this, we'll keep doing that, but I'll make that in a separate video, okay? So finish off networking layer. But yeah, that's fine for now. Okay, we'll see you in the next one. Ciao.